we love it. We have a glitch on one of the symbols. It's fantastic. All right, so what we're going to do today is we are going to kind of combine all the things together we've done in order to make a picture of a function. So we're going to do 3 of these. So naturally, I'm going to send you a graph. You don't have to use this if you got other graphs you like to use. That's totally fine. You don't have to use what I give you. But it's better than having a freehanded. My thought on it. Get your notebooks out. Work down this list and get all the pieces on there so that we can then connect it up. So we know whatever the heck this thing looks like, it's got a y-intercept at 0, -4. I'm going to just do this. So 0, -4. It's got a point right there. I know that. I think my end behavior is wrong on this one. Yeah. We have an x-intercept at 2, 0. So the point 2, 0. It's linear and it's continuous. At that point, I have enough to connect this up. I know it's linear, which means it's shaped like a line. It's continuous, which means I'm never going to pick up my pencil. So I don't even need my end behavior, which is great because it glitched out on us and then scrambled because those are wrong. So we're going to have to be extra cautious with our end behavior. So linear and continuous means this sucker is a line. I'm going to use my chunky marker. It goes through those 2 points, and it is a line. Yeah, these got scrambled sometime when they glitched out. So ignore those for now, and I will make sure we fix the other ones before we get to them. So ignore those for now because they got all glitched out and scrambled. We won't always need the end behavior in order to do it. Okay, cool. So using the words that we have here, we can graph this. We don't have to use everything. If there's something you don't remember what it means, look at the other stuff, see if it's enough. But between the x-intercept, the y-intercept, and the fact that it's linear and continuous, we're good. I just checked the other ones. We're good on the other ones on behavior. This is the only one that got scrambled. They still look weird, but they're there right. Okay, so that's all we need to do on a sketch. We're not looking for anything super specific. It's just got to be best we can. Ideally, on something linear, you'd use a ruler. If I use a ruler on my iPad or on my screen, it gets glitch-tastic. But so for linear functions, for lines, we'll use rulers. So we're going to do another one. We've got a sketch here. It has a y-intercept at 0, 3. It's continuous. This one is non-linear. And it has this end behavior. Those are intended to be arrows. As x approaches infinity, f of x approaches infinity. It's just being a grumpy guess. The little boxes are meant to be arrows. It's just Google Slides and PowerPoints like to argue over what things we used. So again, we're going to fill in the pieces we know. I have a y-intercept at 0, 3. So on my y-axis, 0, 3. We got a point right here. That's the chonkiest point I think I've ever done in my life. Let's do that again. There we go. Normal sane people point. It's continuous, which is great. Means I'm not going to pick up my pen. It's non-linear. So at this point, I don't have enough information to do anything. So we got to look at this end behavior. So this is the stuff we talked about yesterday. As x approaches infinity, as x gets real big, y approaches infinity. So as x gets big, y is going up, which means I'm going to have an arrow somewhere over here pointing up. For the other one, as x approaches negative infinity, f of x approaches positive infinity. So again, as x gets real small, as x goes left and left and left and left and left, my y's go to positive infinity. So my y's are going up. So somewhere on the left-hand side, I'm going to have an arrow that goes up. That is all the information we are given. There are a multitude of options this can be. As long as it meets these requirements, we're good. Because when we do our sketch, it could be as simple as this. You could go wiggle crazy. You could say, hey, you didn't tell me about x-intercepts, but maybe there are some, and you just didn't say anything. It doesn't say there's no x-intercepts. That could be it too. It could be an absolute value. Most likely we'd kind of do this one because it's the simplest one, but all of those were correct. Those were all right. A sketch is not a graph. It's on graph paper. It looks like a graph, but it's not a true graph. You're not going to get points off because, well, you had an x-intercept, and I didn't think there was going to be one. It's just a sketch. It's a guess. A sketch is a guess. So if it says sketch it, you're taking an educated guess. That's all it is, okay? I didn't bring a bomber for today. Bless that for me. We have another sketch to do. come down here and fix these little boxes because Google Sheets is a jerk. These are arrows. So we have a lot of pieces here. Lots of pieces here. We have a y-intercept at 0, -2. Right here. So get your y-intercept on there. Then this time we have 2 x-intercepts. So let's get those on there. At -4, 0, and 3, 0. It's non-continuous, which means we're going to have to pick our pens up. And it's non-linear. So it's not just one line. Let's get our end behavior up here, and then we can kind of make something. So as x approaches positive infinity, f of x approaches positive infinity. So as x gets real big, as x comes this way, my y's are going up. So somewhere on this side, we're going to have an up arrow. I tend to draw it really wide so that I can make whatever choice I want to make on where this line goes. Same thing with the other one. As x approaches negative infinity, f of x approaches negative infinity. So as x gets real small, my y's are getting small. My y's are going down. So somewhere on this side, I'm going to have an arrow. So I can kind of see at least some pieces of what's going on here. Don't just quick swoop them all together because remember, it's non-continuous. So you either need to make a jump or stab a hole in it. So again, there's a gazillion and a half options you can choose. You could like connect these guys up and do something like this and just go, oh shoot, non-continuous, poke a hole. That's valid. You could do something like this, where you just like stop and start stuff. That's non-continuous and meets all the requirements. You could do little pieces like that. That would do it. There's lots of different ways you can do this. I feel like we're going to do something kind of like this and go, oh shoot, it's discontinuous, something like this. It's not better than others. You can just do it with the little hole. As long as you stab a little hole in it somewhere. You can put more than one hole if you want to. I don't care. Pepper it with holes. I don't care. Lots of holes. Stabby, stabby, stab. Poke holes in it. Like a grandma.
Doesn't matter how many holes you put.
Nope. As long as you have at least one, it is not continuous anymore. I went a little crazy on that. We have one hole. That is non-continuous and non-linear. Has the end behavior, has the x-intercepts, has the y-intercepts. Okay, so we're taking all of those pieces we've talked about over the last week and a half and smooshing them together. Right? So we're going to practice that, and I'm going to get the worksheets, which I left on the printer, So I'll be right back because I gotta get them from the printer because I'm organized this morning. So hold that thought for just a second. But that's what we're doing. I get it. There we go. So this is homework 4. Right here, sorry. Thank you for your patience. All right. So we're not going to have another day of notes on this. I know a lot of times we have 2 days on each homework. This is not that kind of day. So you can do the whole thing. There's 4 pictures on here. Work on your intercepts. Is it continuous or discontinuous? All that jazz, okay? Practice this. Remember that we have a quiz on Friday? Speaking of the quiz on Friday, I will tomorrow have a review for you for the quiz. If you want to get started working on reviews early, there is one up on Alex. So there's going to be one on Alex, and there's going to be a paper one that you can do to help you prepare. I know some of us are kind of freaking out. It's okay. I promise it'll be okay. So if you want to start working on the quiz, working on getting ready for the quiz, that's fine. There's a review up on Alex, and it'll give you practice questions. Very, very similar. But I will also have a paper review for you tomorrow, because this is the last homework before the quiz.
So work your way kind of down the list and give yourself the pieces that we have here. So we've got 2 points here. You can plot those 2 points. Yep. Yes. Okay. So it's linear, right? Which means it's going to be straight line. So like a ruler. So put your 2 dots on there. And then can you connect those with the ruler? Yeah, just like that. Since it's linear, it's right there. Yeah.
So give yourself arrows in either end, because it's not just between the 2. But yeah, just like that. That's the first one.
Yes. Because this is not the end point of it, it's just telling us pieces of it. Okay, it's describing it, but it is a function. So they're gonna have arrows on either end. Every time it says linear, you put a line. If it has and behavior, we didn't go through it, but it has and behavior. It has arrows. This describes the arrows. Yeah, that is the easiest way to make it continuous. Mm-hmm. Yeah, just like that. That's just telling you the arrows. This one, since it was linear, we figured out with having a look at it. But this is, when we were describing it, we do these things, we were talking about the arrows, which one went up, which one went down. Mm-hmm. So as x goes bigger, y goes bigger. As x goes bigger, y goes bigger. It has an arrow up this way. So that means y. Yes.
That's what I figured.
Okay. No, you don't have to write anything there. You're just looking at the picture. Okay? Give it a shot. You can do it. I believe in you.
Thank you so much. Yes, sir. I'm coming.
You did fantastic. Of course. I'm never gonna say that it has to match this exactly. So if I told you to sketch this, I'm gonna say, all right, you got it, so it's gonna take this one, and then do that. One, and this out is 12. Above. Not linear. No, it didn't talk, more like homework. Okay, I would review this just like the quiz. If I have more questions on the quiz, it would be a book. But, no, yeah, there's not like vocab. Okay. It's really hard not to throw the flag. I feel like I got a little lame with that moment with that red flag.